In this video, I'm going to talk about the difference between scalar and vector quantities and introduce you base and derived quantities and how to calculate the units of some derived quantities. Let's first define quantity itself. What is a quantity? Well, everything that you can state it with a number or describe it with a number is quantity, like length, mass, force, etc. For example, you can say that the length of the book is 20 centimeters or its mass is 300 grams. Or 20 newtons of force is applied on that. So you were able to apply a number to length and mass and force. So these are quantity. But what about fear, happiness, beauty? Can you say, for example, I have 10 beauties or 4 fears? No, it doesn't make sense. So these are not quantity. Quantities can be classified in two groups. First one is scalar quantity and the second is vector quantity. Scalar quantities have magnitude, and vector quantities not only have magnitude, but also they have direction. So you must pay attention on direction. If a quantity had direction, it's a vector quantity, and if a quantity didn't have direction and just magnitude, it's a scalar quantity. Let's go through some examples. What do you think about length? Is length a scalar quantity or a vector quantity? Well, it's pretty clear that length is a scalar quantity. You cannot say, for example, the length of the book is 20 centimeters east. It doesn't make sense. So length is a scalar quantity. What about distance? The distance of two cities is, for example, 20 kilometers. It doesn't matter. It's 20 kilometers north or 20 kilometers east. You cannot specify direction for distance. So distance is a scalar quantity. But let's say, for example, the car has been displaced 4 kilometers east and 20 kilometers north. So since we were able to apply direction to displacement, displacement is a vector quantity. What about speed? What do you think about speed? Is speed a scalar quantity or a vector quantity? For example, we can say the car is moving at 30 miles per hour, and we didn't talk about direction, so speed is a scalar quantity. But when we say the car is moving at 30 kilometers per hour east and 24 kilometers per hour north, we are talking about velocity. Since we are applying direction to velocity, so velocity is a vector quantity. We said 20 kilometers per hour, for example, east. This is magnitude and this is direction. So we were able to apply both direction and magnitude to velocity. So velocity is a vector quantity. What do you think about acceleration? For those who don't know what acceleration is the change of velocity over the change of time. We can say, for example, the acceleration of the car is 2 meters per second squared east. We can apply direction to acceleration too. So acceleration is a vector quantity. What do you think about force? Again, we can say 20 newtons of force is applied on the book east, or 30 newtons of force is applied on an object north. So we can apply direction to force too. So force is a vector quantity too. What about temperature? Is temperature a scalar quantity or a vector quantity? Can you say, for example, the temperature of the room is 25 degrees Celsius east? It doesn't make sense. So temperature is a scalar quantity because you cannot apply direction to temperature. Let's talk about base and derived quantities. The units of all quantities are not independent, fortunately. We define some quantities as base quantities like length, time, and mass. And we define a unit for them. For example, the unit of length is meter, the unit of time is second, and the unit of mass is kilogram. The rest of quantities units can be written in terms of base quantities. For example, area, which is multiplication of two length times length. Okay, we know that the unit of length is meter. Again, the unit of length is meter, so unit of area will be meter squared. What about volume, for example? Volume is the multiplication of three lengths. So the unit of volume is meter cubed. Let's find the unit of some derived quantities. What is the unit of A, acceleration? For finding the unit of acceleration or everything that they give you, you must write a formula at first. We know that, for example, the formula for acceleration is the change of velocity over the change of time. Then you write the unit of velocity. The unit of velocity is meter per second, and the unit of time is second. So the unit of acceleration is meter over second squared. What about the unit of force? We know that force is equal to mass times acceleration, A. And we know that the unit of mass is kilogram, and the unit of acceleration, as we calculated here, is meter per second squared. So the unit of force is kilogram times m over second squared. What is the unit of pressure? Think about it. Well, pressure is defined as force divided by area. The unit of force is kilogram meter over second squared, and the unit of area is meter squared. So as you see here, meters cancel each other, and what is left is kilogram over meter second squared. So this is units of pressure. So what about units of work? Work is a form of energy. So if you're able to find the units of work, it means that you have found a unit of energy too. Work is defined as force times displacement times cosine theta, which we know that theta is the angle between force and displacement. But we know that cosine theta is a number between -1 and +1. So cosine theta is unitless because it's a number. And the unit of force is kilogram meter over second squared, and unit of displacement is meter. So if you multiply these two terms, we get kilogram meter squared over second squared. So this is the units of work. And in this way we can find the units of all derived quantities. Till the next video, goodbye.